Hey, Dr. Romano, more physics?
Yes, indeed. I'd like to go over a question with you on flow rate. Let's have a look at how we would handle problems like this. What is the volume rate of flow, or flow rate, from a 1.60 centimeter diameter faucet if the pressure head is 12 centimeters from the ground? Let's look at the scenario. This is the start of the problem. I'll call this point A, and this is point B, and we're up 12 centimeters high, so it's like a faucet. I think it's easy enough. Now, before we start, this is the formula we're going to use. Q stands for the flow rate, and that's what we want to find. Flow rate, Q, equals area times velocity. All right, so we need to get the area, and we need to get the velocity to get the flow rate. I'm going to derive a formula you need to know, but I want you to understand it. At the top, we have nothing but potential energy. At the bottom, all that potential energy is converted into kinetic. So the potential energy at A equals the kinetic energy at B. You set potential equal to kinetic, cross out the mass, bring the 2 to the other side to get rid of the half, square root it. This is a set formula. Velocity equals the square root of 2gh. That's the formula you would use on your exam to figure out the speed, the velocity of a fluid that's coming out of a hole. So if I wanted to know how fast this velocity is, you would use this formula. So if you square root 2, there's the g, there's the height, 0.12 meters. You found the velocity is 153 meters per second. Let's get the area. Well, the diameter over 2 is the radius, so we know that the diameter is 1.60 divided. You get 0.8 centimeters for the radius. 008 meters is the 0.8 centimeters. Now, if you looked at a faucet, it's circular, right? If you looked up here, this is a circular hole. So area of the circle is pi r squared. There's the pi, there's the radius, and we come up with 002 meters squared. And the kill. The flow rate now is the area we just found, 002, times the velocity of 153, and we get 3.07 to the minus 4th meters cubed per second. All right, let's try another one. A 15 centimeter radius air duct is used for a room. The room is 8 by 8 meters times 5.2 meters times 4.6 meters every 8 minutes. So this air is going to be coming through the room in 8 minutes. How fast does the air flow in the duct? Now, before we do anything, let's write the needed formulas. Flow rate is Q. Now, make sure you got these formulas down. Q is volume over time, area times velocity. Anytime you're dealing with a question involving fluids and there's time involved, you should write this formula down immediately. All right, we're looking for this term here. So that means we need to know the time, the volume, and the area. I think we can do it. The volume is the 8.8 times 5.2 times 4.6, and as you multiply them out, you would get cubic meters, 210.5. Easy enough. Area is pi r squared. We always assume the duct is circular. Pi times the radius is 0.15. Square it, we get 0.765. We're almost there. We then take 8 minutes and convert to seconds. And we got the time. Now we just plug in. Volume over time is area times velocity. We know the volume, the time, the area, and that's the way you would get how fast the air flow is in this duct. All right, I hope this gives you an idea of how to deal with anything to do with fluids and flow rate and how to deal with time of flow.
Thank you, Dr. Romano. You really explained that, so I think I got it now. I'm going to have to go over that a bit.
All right, you do that. Good luck to you. Bye-bye.
You have a lot of books in this office, Dr. Romano. Good day to you, sir.